Hello, 8th graders. We're going to talk about section 1 of chapter 15 today. I hope you and your families are doing well. Everybody's hanging in there. Looks like the weather might get a little bit nicer towards the end of the week. I wish Mother Nature would turn the heat up, though, and hopefully she'll do that by this weekend. Okay, section 1 of chapter 15. It deals with temperature and thermal energy. There's two big things that you need to know here. And temperature and thermal energy are completely different, as is heat. Do not get confused with these three topics, okay? One thing that we need to remember is kinetic energy and potential energy. As I've written down up here, take a look at kinetic energy. Remember, that's the energy of motion. All things that are moving have kinetic energy. Your heartbeat, your breathing, these are all parts of your body that have kinetic energy. Things that are motionless or not moving, we say have potential energy. Now, temperature is the average of all the kinetic energy of all the particles in a substance, okay? So when we take the temperature of the air around us, we are taking the temperature, or we're finding the average of all the moving particles in the air around us. We take our body temperature, we're actually taking the temperature of the molecules that are moving or the particles that are moving within our body, whether it be our bloodstream, all of that. But if you think air temperature, for the most part, that's just all of the particles that have some kinetic energy that's causing them to move. And what temperature does is it measures the average of that kinetic energy, the average of the moving. So if the particles aren't moving very fast, what kind of temperature we're going to have? Yeah, it's going to be lower. It's going to be colder, as we say. When particles are moving much faster, they have a lot more kinetic energy, therefore the temperature goes up. We have a warmer temperature, okay? So if we look at this, right, the temperature of average of all the kinetic energy of the particles in a substance, the more kinetic energy, the higher the temperature. Why? Particles are moving faster and collide with one another, and we know that when things collide, there's going to be friction. And when there's friction, there's more what we call thermal energy. And we'll get to thermal energy here in a second. Okay? Now we measure temperature. We know how to measure temperature. We measure it with a thermometer, and we know that in the metric system that degrees Celsius is our measure of temperature, just like we use millimeters, centimeters to measure distance. Okay? Now, remember how I said when all those particles will collide and there's more thermal energy because of the friction, all right? It's not producing heat. Heat's a totally another concept that we're going to talk about in the next section. But right now, I want you to focus on temperature and thermal energy. Thermal energy is the sum, the total of all of the particles within that substance, whether they are moving or not moving. The ones that have potential energy and the ones that have kinetic energy. So something can have much more thermal energy, but have a very low temperature, okay? So thermal energy is the sum, the total of all the potential and kinetic energies of all the molecules in that substance. Now, for example, take a giant iceberg versus a pot of boiling water. Which one's going to have more thermal energy? Well, we have been taught, or we think thermal energy means warm, and it's got to be the pot of boiling water. Well, that's not true, okay? Because there's only a small amount in that pot of water. It's not going to have as much total potential and kinetic energy of the molecules like a giant iceberg would, okay? That giant iceberg is going to have a heck of a lot more thermal energy because it's bigger. There's more potential and more kinetic energy going on. Though the kinetic energy may be lower, so it's cold temperature-wise, but we have more molecules going around. Take a look at this. They talk about this in the last paragraph of section 1, right before the questions, that if we had 2 glasses of milk, and here I just made an example. If I had 10 milliliters of a liquid at 5 degrees Celsius, and I have another beaker of 10 milliliters of a liquid substance at 5 degrees Celsius, okay? We add them together, we're going to have 20 milliliters total, but my temperature isn't going to change. It's not going to warm up the temperature of the liquid when we combine them. But my thermal energy is going to rise because I've got more total potential and kinetic energy in 20 milliliters than I would in each of 10 milliliters. But my temperature is going to stay the same. Okay? Remember, thermal energy is the total sum of all the potential and kinetic energies, whereas temperature is just the average of only the kinetic energy of the molecules or particles in that particular substance. 2 important things, 2 important concepts, and definitely 2 vocabulary words that you need to know here. Okay, just wanted to take this time and have you go over this. There will be a short assignment from YouTube. I'm sorry, from Brain Pop that I want you to do. I don't know exactly which one yet, but that will be coming out shortly. Okay, again, I hope you are all well. Temperature and thermal energy, remember the difference. Temperature is the average of the kinetic, thermal energy is the total sum of all the potential and kinetic energies of the molecules in that particular substance. Stay well, everybody.